Join us for our conversation about digital actuation of interventions, present and future. We are Team Miovision. My name is Brian Hoeft, and with me I have Craig Milligan and Greg Barlow, a little closer to my mouth. And we're going to have a great conversation here. So the way it's going to go is I'll give a brief introduction of myself. We'll let Greg and Craig introduce themselves, and then we're going to go into some very thought-provocative questions. And so real quickly about myself, again, my name is Brian Hoeft. I am the Director of Customer Advocacy and Relations for Miovision, and I've been with Miovision for several months. If you go back a couple of years ago, I was the Director of the Traffic Management Center in Las Vegas, known as FAST, and we did a lot of cool stuff there. We did a lot of technology, we ran all the traffic signals, we did all the special events. So a very exciting job, but that's beside the point because the stars of the show are Greg and Craig. And so I think I'll hand it off to Greg to go ahead and introduce himself, and let's go.
Hi, I'm Greg Barlow. I'm a software architect at Miovision. Miovision acquired my company, Rapid Flow Technologies, back in October, and my background's really in adaptive signal control. But I work on a lot of things at Miovision, looking at ways we can bring technology to the intersection, to think about the future of how a digital intersection can bring benefits to people on the road, travelers, but also all of the agencies that have to maintain those roads, OEMs that make the vehicles that use them, all those things.
I'll just introduce myself. Thanks a lot for coming out to hear about what we're working on. My name is Craig Milligan. I'm a road safety engineer, and I was the CEO and co-founder of Microtraffic before Microtraffic joined Miovision in February of this year. And so my background is in road safety engineering, and at Miovision, I'm a senior product manager for road safety.
All right, thank you, Craig and Greg. So what you're seeing here is kind of some nice outcomes, things going on with Miovision. We've picked up Greg, we've picked up Craig and his work. As you may have heard, we also just acquired GTT. They're a part of the family. So there's a Summer there, so say hi to her. Visit both of our booths. So we're going to focus on the interventions. And one of the key things that I'm hearing in the conversations at the conference is it's great to get together, see everybody, talk about this, but we really need to implement the solutions, save lives, do things much better. And that's what we're going to bring to you is our approach on that in this conversation. So I'm actually going to start with Craig to kind of talk through Microtraffic a little bit. He has a real cool slide, and he's going to get into the weeds a little bit. We're all technical here, and I think we'll like it. And let's go, Craig.
So we all know that road safety is a huge problem, right? It's one of the leading causes of death worldwide, and top cause of death for young people. And one of the things we wanted to do was a way to measure risk and understand it before fatalities happen instead of after. So what we built at Microtraffic, which is now part of the Miovision family, is a video analytics-based near-miss measurement tool. And we've deployed that to 100 cities. And what this allows cities to do is to just discover risk factors and respond to them. Okay, and the video analytics measures near misses, and then it describes those near misses, how serious they are, using something we invented called a kinetic energy-based safety model. And that just basically is a way to say how likely is it that someone would have got injured if that near miss materialized into a crash. And then we can classify the severity of that. Once we see patterns of near misses emerging, we actually predict that a fatal or injury crash is on its way. In fact, there's a predictive model that's 94% accurate to say in the next 5 years what your likelihood of having a fatal or injury crash is, just based on the near misses you measured over a 60-hour study. Okay? And that was never possible before until the kinetic energy-based approach to near misses was invented. Then based on that prediction, the prediction is very precise. So It will measure 60 different types of risk factors at the intersection, and will tell you 1, 2, or 3 of them where that particular precise risk factor is elevated and problematic. And so the agency can go in with a pretty laser-focused intervention to reduce that risk. And there's a slide here on the power of prediction and precision. So this is a study we've done a bunch of near-miss diagnostics in Texas. This is one in Austin. And you can see the temporal distributions of near misses and the severity scatter plot before they did any intervention at Lamar and Morrow, and after. And this is one of 60 risk types. This is just for a northbound left versus southbound through near miss measurement. And what they did is they isolated the time of day when it was worse and how it was related to signal timing. So they said, during a certain time of day when it's the worst, we're going to change this signal operation to protected only phasing. That's why in the right-hand side, between the hours of 3 o'clock and 7 o'clock p.m., there's no more risk. There's no more risk events because they changed it to protected phasing. During the other hours of the day, they adjusted the signal splits. It was run in protected permissive, and they elongated the protected portion of the protected permissive phase. And what they achieved was not a total elimination of interactions, but they got over 60% reduction in vehicle near misses. But what's even better here, they got an 80% reduction in vehicle versus vulnerable road user events. So this was one risk factor. They measured some other risk factors that they implemented at this intersection, but it's just an idea how you can use this digital approach to diagnostics and come up with interventions that you can apply to that intersection.
And that's one of my favorite slides, and one of the reasons is it has a lot of detailed information, but look at it kind of from the high level. You got the red boxes down to the green boxes. Obviously red is worse than green, but once the data is collected through the near-miss analytics and the countermeasure is deployed, you have fewer events, fewer circles. You've drifted away very nicely from the red box. And then when you look at that bar chart, that temporal chart, you've completely eliminated incidents in several of those time slots. And so this is all done pretty much now. This is something that can be done now. So microtraffic, the safety analytics, very exciting. Let's have Greg talk about the adaptive system. And one of my takeaways from that is that obviously vehicles are important, but the transit user, the pedestrian, the bicyclist, sometimes those users are seen as constraints to some of the solutions that we try to deploy. But as you'll hear, this is all being taken in to make it a better system for everyone. So Greg.
Yeah, one of the real focuses of the way that SureTrack, our adaptive system, works is it thinks about everyone on the road. The goal is really to improve mobility for everybody that needs to use an intersection and to meet them where their needs are, not where the system's needs are. So if we think about pedestrians, how do we move pedestrians efficiently through an intersection, respond to when they want to cross, give them the right kind of service, and do that in the context of all the traffic. Because if you choose someone to favor, everyone else is going to suffer a little bit. If we can do it in a way that is thinking holistically about all of the modes, that's where you get real mobility benefit. That you can keep roads that are reasonably in human scale instead of expanding the size of them. That you can have safety benefits that come just from people having a better experience on the road, and that maybe you can then bring in other things. We'll talk about it in a little while, where you can talk about, think about safety as part of control. But really, the way that this the SureTrack thinks about this is that we want to bring in as much information as we can to give us a good idea about how to optimize for everyone on the road. To do that in a way that's real time, so it's thinking about the actual travelers on the road. It's doing it in a way where we're really thinking about the different contexts. Is it a corridor that has lots of vehicles? Is it an urban area that has a lot of different modes that are interacting all at once? How do we make transit work effectively in the context of everybody else? So, that's and the goal is to do that without treating people like constraints, but to optimize for people, for travelers on the road.
So very exciting, very important, and very consistent with the messaging that we're getting here at this conference. And if you recall, or maybe don't, the DOT today made an announcement about a Safety at the Intersections challenge. And so that information is now available. Obviously something that's going to be exciting for us to look at. So I'm going to turn back to Craig. Question for you. Question number 2. We can make this like the newlywed game. So we're talking a lot now about the now, what's happening now, but obviously with our acquisitions, with our collaborations starting to develop, there's going to be opportunities to take what's happening now and enhance it either further. So I'd like you to elaborate on how we see that happening. We'll pivot to the future part of what's going on with our solution set.
Sure. Happy to talk about what's coming up in the future, and it's exciting. Okay, we're moving to a digital intersection, which means the problem can be detected digitally, the solution can be optimized digitally, and that solution can actually get executed and implemented digitally with no human intervention. And like Greg said, there's a lot of objectives you're going for at the same time in transportation. And I'll just give an illustration of one of that, something we may hope to do in the future, okay? And to give an example of that, I want to talk about leading pedestrian intervals. That's when you give the pedestrian 5 to 7 seconds of head start before the vehicle traffic going in the same direction is released from red. And that just is aiming to reduce conflicts between right and left turning vehicles and pedestrians walking in the crosswalk that they could get hit as the vehicles exit the intersection. You have some cities that have kind of indiscriminately put that leading pedestrian interval at every single intersection on every phase of that signal, whether it's needed or not, whether there's even a pedestrian there or not. And if you just think of the degradation of overall mobility that's been caused by, in the name of safety, it's massive in the times where it's not needed. So one thing we envision for the future is that leading pedestrian interval would turn on or off automatically based on where it's needed by the presence of pedestrians and the amount of risk that is present live in the moment. So then the adaptive system can decide between your overall objectives to increase traffic flow and minimize overall delay to the intersection by either not having the leading pedestrian interval or shortening its duration, applying it only to one leg of the intersection and not the other. And this is the kind of thing where you can say, we're going to bring safety benefits without compromising mobility by making them precision targeted in location and time. And that's just one example. There could be 100 other safety interventions where sometimes the safety engineers have to debate with the mobility people. Like, I want to do this to make it safer. And then the people for the traffic signal timing are like, no, that's going to reduce the level of service on this intersection. But I think that as safety engineers, we can be a bit more credible when we say we want to precision target this and digitally actuate it only when it's needed. And that is my view of where we're going in the future. And it opens up what Greg is talking about multi-objective optimization.
Right. That's really the benefit that you get with a fully digital system with the kind of inputs that we can get now that you couldn't get a couple years ago, right? Knowing information about safety and conflict, knowing information about where a pedestrian is, knowing more information about transit than just it's coming and maybe it wants priority, but knowing sort of when it's arriving and how can we predict these kind of pieces means we can be holistic about how we control an intersection. We're not doing it based on very strict rules that one person thought were a good idea. It's based on all the needs of the system, right? We're thinking about, a transit agency and what would they like to see. But the people who have to operate that intersection day by day, the city or the state that operates that intersection, what do they need? All of those things can be combined in a way that doesn't involve hard, fast rules, but more a holistic optimization, and as we get more information, we can combine that information and get better and better results.
I like what you said, that this stuff was not possible just a few years ago. And it's because the digital building blocks are starting to get rolled out. Okay, you can't do this with inductive loops. It's just not possible. You can't do it unless you have a compute platform living at the edge that can run perception on digital sensor feeds into a compute box that's running perception on that. Once you start to put that digital core to the intersection, all kinds of applications are enabled that were not even possible. The AI to do the perception didn't exist a few years ago, and so it's really cool what we can enable once we have those digital building blocks, and the best stuff is still coming. So that's why I'm positive about the future when you ask us to look forward, Brian.
Right, it's very exciting. It's the future, but it's also the now. Some of the limitations are the fact that the analog infrastructure, the stuff that's been around for a long time, does still exist, and there aren't always clear ways to improve on that. But hats off definitely to the federal government with all their federal funding, their grants, their opportunities. We're definitely collaborating on those opportunities. You're seeing an exciting peak at the near term and actually reality in some locations and what's going to be coming up next, but in a partnering way with all the different players, we have a chance to advance this really, really nicely. So I'm going to pivot over to Greg and just kind of talk about, I'm using the words, the box and the platform. So again, the box is the old school. Think of an intersection, think of a controller, think of that point of view. But what is the overall platform as we start to bring in these other solutions so that, again, everyone at the intersection is safe, they're happy with their travel, and so forth. So take it away.
I think our vision at Miovision is to think about being a platform for all the applications that are necessary, not to provide every one of them ourselves, but to make it possible for all these things to coexist. There's a long history of selling a piece of hardware to do a job at an intersection, and maybe it plays well with another piece of hardware that's there, maybe it doesn't. But we're in a place now where it's possible to have one compute platform that lives in an intersection that you can run applications on. So if you're a city, you can add something that you want that, it's a weird idea, right? But it doesn't make sense to have 800 computers at an intersection, and we're headed that way. You're going to need more than one, but it needs to be an idea where you can have applications that help people running an intersection as opposed to hardware solutions that just solve one problem and do it maybe well, but don't do it in the context of everything else. That's what we think of. That's if you look at what Miovision has done over the last year, all those pieces go into that platform, and that's a start internally. But if you think then opening that up to others to build on, startups who maybe don't have the ability to have their own box, but competitors too, because in the end, the goal is to serve the traveler, and to serve the traveler, we need to serve the person who's serving the traveler, the engineer, the agency. We have to provide them with a solution that lets them do that.
Something you said about the platform really resonated with me, and I would say that when we with our safety solution, which is quite niche, you talk about individual solutions, decided that it would make sense for us to join a bigger company, and we elected to do this with Miovision. We were fortunate enough they were interested. The number one reason we went with Miovision, one was the culture of the team, but a very close second was the platform. Okay, the platform is so powerful and so exciting, and what we're actually doing is we're putting our applications as if we were like an external startup into this platform. So we're building an app. We're kind of test driving this concept that any other company could build an app and put it on the Miovision core. We're doing that. We're like an outside startup. And what this is going to do, it's going to be a change, kind of like the iPhone, where Apple's not making all the apps, but they're providing this platform that can be shared, and then the innovation is just going to go through the roof as it opens up to the whole community, and we're really excited about that. That's like one of the highest reasons why we picked Miovision.
So a lot of nimbleness, a lot of things happening right now, a lot of digitalization, which are key themes again throughout these discussions. I'm going to briefly put on my hat as a former traffic management operator, and Craig was talking about the LPIs, the leading pet intervals, and we would get at a traffic management center, like you all do if you work at one, you get complaints, you get concerns, you get called out. It can be a little bit challenging and intimidating. And then sometimes maybe you overreach on that solution. Like Craig was saying, LPIs for everyone at every intersection, at every location. And yeah, that's going to add some value, but if it's being deployed that way, it's also going to create a lot of harm, and potentially it might even be taken out. But now that we can be nimble, now that we can be precise, now that we can potentially even automate it so that a human doesn't have to punch a button to save those sorts of things. That's where we're going with these solutions, and they are great. And then the other thing is, and this was a theme yesterday when we had the digital infrastructure workshop, they talked about the performance measurement, the SMART acronym for how to measure things. All of this data, all these capabilities are allowing us to also quantify what's going on. So it is very informed decisions that allow these good things to happen. So as we've moved a little bit into this, about 20, 25 minutes, I'd like to take a brief opportunity for anyone who wants to ask a question before we come back up here and make a few more conversations. So seems like people are, they've joined us. You're not so much on phones, you're actually listening or faking listening, but I'd like to hear from the audience for sure. So is there anyone who would like to take a mic and ask us some questions? Throw some curveballs, don't give us a softball, let's go. All right, thank you.
Thank you so much.
And please introduce yourself as well.
Yes, from the National Research Council in Canada. So just quick question. Deep learning is progressing very, very fast. Is there any challenges regarding the use of deep learning in the scientific section? And the other one is when we talk about edge computing versus spy computing. Is it, can we consider it as a replacement of edge computing?
So can I start with the Yeah, can I start with that so I don't lose it? Is that cool? Yeah, I think it's important to note that there are different reasons to do cloud computing and edge computing. I don't think you can do one or the other. And I didn't talk a lot about this, but Miovision, we have a vision of providing a platform for both, right? You might use one, you might use the other, you might use both of them together. But there are some things where if you want to aggregate data across a large area, cloud computing is great, right? I can't.
He said sky computing, but I think you should just go on there.
Okay. In any case, but there are a lot of applications that need edge computing, right? We need to be at the intersection with low latency to make safety critical decisions, but also really, decisions for operation that need to be made, in a real-time basis with second-by-second data. That's what SureTrack does, and I don't think you can replace that. I think the questions are how do you sort of balance those two things together?
Yeah. With the low latency demands of operating an intersection, it's wishful thinking to think that it can all be done in the cloud. Okay, the future of the digital intersection must include an edge compute component in every traffic cabinet. That's my opinion, an extension of what Greg was saying. On the question about deep learning neural networks for digital intersection solutions, and you asked about challenges and the rapid progress. This is one of the most exciting fields in the world right now. It's a revolution that started in 2014, and it's just picking up steam every year since then. And deep learning neural networks are at the core of this sensing and perception stack run by Miovision and run by Microtraffic. So they enable everything that we do. And I think that you asked if there's challenges with them, for sure. There's some things we'd like to do better. We'd like to see further. We'd like more stable tracks. We'd like a bunch of stuff. But like every 6 months, there's a breakthrough in deep learning, and we contribute to those. and it just opens up more and more possibilities of what we can do for road authorities and agencies. So it's a fun time to be in traffic. It's a fun time to be applying this cutting edge of AI to traffic problems. Yeah, thanks for your question.
Yeah, you did a great job of setting the bar high for questions. So somebody needs to come up and ask another one. Who wants to stump us? Stump the chump. Hold on, my knees are a little tight, so there you go.
This is Brian from Electronics. What open data exchanges and messaging standards are you considering embracing? Or is everything going up into your own proprietary cloud platform?
So I'll give you an example. We were integrated with Miovision before we joined Miovision, right? We used an open API that they already provided. We were on a separate computer in the cabinet, but we used that to get information from the perception system. We use that to make decisions, and we communicate with the controller using NCCIP 1202 open standards, right? I'm a firm believer in open data, open standards. If you do things in a closed way here, I think that's where you can get, it doesn't help customers. Like an open standard, and I mean, you'll hear this from USDOT and from lots of other people, is that you can't always have an open standard that the entire industry is agreed on. I think there has to be innovation, and that feeds that process. So sometimes you get ahead of it. But I mean, the goal here is to have something that other people can build on, and that maybe then it contributes to a standard, it becomes part of a standard, but that wherever there is a standard that we can adopt, we want to adopt it.
Yeah, that's something I really like about Miovision as well, the commitment to openness. We publish data by open APIs, we'll interact, we support interoperability. We're launching Miovision 1, at one place where you can see all your traffic data and you can see your near miss data. Let's say you use another platform where you visualize all your traffic data and you want to show the near misses, you can just get it by API, okay? So we're not going to force you to get the Miovision 1 map and integrate everything. If you want to show it in another one, you can just pull it by API. You may need to build your own dashboard with it from the data, but it's a great thing. And Miovision is about impact, right? A lot of people work at Miovision because Miovision is about making the biggest impact on quality of life possible, and you just can't do that if you close your systems up to other systems.
All right, thank you. Thank you for the question. Great responses. I'm going to echo on that a little bit. I was in the session where Michael Morris from North Central Texas Council of Governments was talking, and he was talking about the approach where he agrees with the theme. We need to be doing these things right now as much as possible, and then we need to gather that data so that it can report on the specific projects, but also that data can then aggregate into the cloud, into the solutions, so that others can benefit from what's going on there. So it's the now, and then it's the slowly delayed response of some real nice benefits that are going on. So unless there's a burning question, and of course we want some burning questions, I'll take a pause from the audience questions. I'll have us have a little bit more conversation up here, but start thinking of those zingers, and we'll come back to the crowd in a few minutes. But what I want to do now is, everybody again, take a look at the title, Digital Actuation of Interventions, Present and Future. So based on what we've been talking about, and based on this feedback, what does that mean to you as we move forward? What does the title of this mean to you as we move forward?
I think for me, nobody has a full solution. Nobody should. There should be room to do new things on top of the things that have come before. And I think if I'm trying to do anything at Miovision, is to make it possible to actuate new things that people are trying to accomplish, whether that's inside our own company or that's other people. That we make it possible to serve the traveler on the road effectively by allowing innovation to come to the intersection in an easier way. That's my goal.
Yeah. For me, it's about digitally detecting that the problem is there, and I said this earlier, digitally deciding what the best solution is, and then digitally implementing that solution. So GTT, Opticom just became part of the family at Miovision, and they're doing that, full digital actuation of interventions. And and emergency response times are faster, and crashes with emergency vehicles are down. That's a perfect case study. So to be honest, some of the stuff we did at Microtraffic, we were digitally detecting problems and then passing it off to human solution optimization and human solution implementation. Now we're building towards doing the last two steps digitally. So that's the future part for us. But we've had a breakthrough in digital problem detection in terms of diagnosing risk. And that's made a huge leap forward. And getting these next two steps, kind of like GTT Opticom already has, is going to be another leap forward in road safety. So that's my take on present and future, Brian.
Okay, thank you very much. And what I like to do on these events is sync them up with what, again, the overall tone of the conversation is. But we don't want it to be just that conversation. We want the actions, and you're hearing a lot of nice examples about that. But another thing that I like to do is the themes of the bipartisan infrastructure law. There's 4 key themes that I keep hearing. Safety is number 1 and should and always will be number 1. Number 2, in the past, they've talked about managing congestion, different things like that, but it's about economic strength, and that goes hand in hand with making sure that your roadway system is efficient. So number 1, safety. Number 2, economic strength. But I want to get you guys thinking about numbers 3 and 4 and how these tools can be beneficial to those. So number 3 is sustainability, greenhouse gas reduction, making our planet sustainable for the future generations to come. Number 4 is equity, making sure that everybody is equally served and has the opportunity to have safe travel, opportunities for travel, because when you dissect the safety numbers a lot of the people who are less well off in society are disproportionately being harmed. They're being killed, they're being seriously injured because of everything that's going on. So whether it's directly related to the products that you guys are responsible for, or just kind of in general, I'd like you to reflect on those last two, the sustainability and the equity.
I can say something about the sustainability part, and it ties in a bit to equity. So there was a researcher in the UK who came out with a study and a bold claim that mode shift to cycling is 10 times more important to the decarbonization of transport than electric vehicles. Okay, for a number of reasons I'm not going to get into, but it's a zero emissions mode, right, with no upstream or downstream emissions from it. But people are not biking because they don't feel safe. Okay, there's been a 600% increase in dedicated bike lanes in the U.S. in the last 10 years, but we're stuck. The best cities have 6% mode share for cycling. The best, like Portland. Okay, most it's 1%. And people are not biking because they don't feel safe. And they're right that they don't feel safe because it's twice as dangerous to bike than it is any other type of travel mode. So if you, this lack of safety is connected to a lack of mode shift, which is connected to a lack of progress on sustainability and decarbonization. We just worked with the city of Vancouver they built a bunch of bike lanes. One of their goals is to be the greenest cities in the world with a super high mode shift of cycling. And they said, we built these bike lanes, but we want to take stock of how safe they are. They measured the near misses. They precisely diagnosed some safety problems. They implemented interventions. They weren't digitally actuated, but they were interventions to improve the safety. And then they put the video back up to measure what happened. Near misses were down by 60%, and cycling was up by 60%. So when people feel safer, they're going to cycle. There's a lot of bike lanes I would not take my kids on, but if they were safer, I would get out of my vehicle, and it would contribute to sustainability. So that's how I think some of the two can go together. There's a lot of other ways that optimizing traffic and what Greg does can make a huge impact on sustainability as well.
Yeah, and that's how SureTrack got started, was to think about sustainable traffic control. That's the original funding back when we were at Carnegie Mellon University, was focused entirely around how do we make a signal system that has fewer emissions. And we weren't thinking about everybody else, we were thinking mostly about vehicles. But one of the big keys to mode shift is easier movement if you're on foot or on a bike or in transit, for example? How do we make those more appealing and easier to use so that people who can mode shift will? That's the biggest way to make an impact for sustainability and for equity, for people who don't have a choice, right? They need to use those modes, and those modes then become easier to use, more efficient, and they get mobility improvements that we're not harming others by doing that. It's a net benefit for everybody.
Thank you for those responses. And I'll kind of answer my own question with a little bit of a use case example. Again, going back to my experience in Las Vegas, but I'm thinking of a big intersection, Flamingo Avenue, like 8-10 lanes, Maryland Parkway, again, 8-10 lanes. It's near universities, schools, commercial districts. In Las Vegas, we are very, very reliant on the fixed route bus system. So you got your east-west buses, you got your north-south buses, and you have a lot of people who work in the resorts, on the resort corridor, who are doing the housekeeping. They're kind of doing the mundane types of jobs. They are very, very reliant on a safe and reliable transit system. So they may be taking the bus in the morning to go to the Strip, and they're riding on Flamingo Avenue. And then they have to transfer to Maryland Parkway to go from westbound to northbound. But that transfer on a wide intersection can be quite chaotic. And then think of people who don't have the luxury of necessarily being 5 minutes late for work. You're too late for work, doesn't matter if the bus was delayed, if there was a crash, whatever it is, that could be pretty detrimental to those particular travelers. So they are concerned about making that transfer. They get off the westbound bus, they see the other bus is pulling up, and they're scrambling unsafely, potentially across the intersection to make that transfer. So now think of all the pieces of the puzzle that the solutions we're talking about could come to weigh on this. And there's another solution we haven't mentioned, but one of our early acquisitions was TrafOp. So here's a great acronym, ATSPMs, Automated Traffic Signal Performance Measures. So you get all that data so that you can more effectively quantify the performance of the intersection. Then you bring in the adaptive signal control to make sure that the Flamingo corridor is being a little bit more smooth. It's not stuck on fixed time of day plans, regardless of what's going on. That's a big benefit there. Then you bring in the safety analytics. So when there is that mad dash of people trying to make that transfer, we can find out what's going on, and maybe we can make some very informed decisions to try to alleviate that. Something with the leading pet interval. Maybe we do some re-signing, striping, something like that. Maybe we can factor something into the transit operations, which bingo leads to what just happened a week or so ago. Now we can work directly with GTT and the Opticom system and everything that's coming down the road to make that work a lot better. A couple years ago, Vegas, they won a Tiger Grant, back when it was called Tiger Grants, to liven up the Flamingo corridor. And one of the things they wanted to do was look at transit signal priority. There were some concerns about the outcomes of the TSP that was going on. We had to dig through 3 distinct data sets. We had to go to the Swiftly data, which quantifies what the buses are doing. We had to go to the traffic aware controller data to quantify what the signal system was doing. And then we had to go to the Opticom data to see if that was all syncing up. And then we had 3 or 4 people scrambling to try to merge pivot tables, all that stuff together. Now all of that stuff combined is being digitized, it's being done in the cloud, it's preventing problems before it can happen. And when you check those boxes, you check the box for safety, you check the box for economic viability, because now the workers are having better opportunities. You check the box for sustainability, because you don't have all this idling going on. Another big problem with sustainability would be for the crashes. If your intersections are unsafe, there will be crashes, there will be lane blockages, there will be delays that contribute to that. And then you're serving the people who need it the most, the less well off, and you're being much more equitable. So it's an exciting time to get all of this teed up and ready to go. So with that motivation and that energy, is there anyone who wants to fire a question at us? Let's take another round of questions, but I got some more top secret questions ready to give to Greg and Craig too. So, but anyone, Jim Meisner, do you want to ask us a question? Or Jim or Will from our friends at HDR. See, I'm even calling you out. I'm going to call somebody out over there at the booth. Somebody from Hezai LiDAR, come over, ask me a question. Okay, or maybe I'm just being too scary.
I was thinking about your example while maybe they think about a question. I don't know how many video clips I've seen after the near misses run where it extracts and serves up the video clips, and you see people running in desperation for the bus. They got off on one corner and they're going to the next corner, and you can bet that in their mind they know if they're late they could get fired, right? And I don't know, it's challenging to watch that because I mean I got my new boss in the back corner here. If I'm 5 minutes late for work, he's not going to fire me. I don't think. Probably not. I haven't got to know him very well yet, but I don't think it's going to happen. But it's not the case for everybody. And I've seen them running, and so we look at that and we say, hey, if you move this bus stop from near side to far side, all of this mad dash would stop. And then the traffic engineers bring that to the transit agency, and we say we can't move that to the far side because then they have to stop for the signal and stop on the far side of the intersection, and it's going to add this extra time to every route. So this is one thing I'm really excited about, and it ties into GTT. Okay, so what if the bus doesn't have to stop at the near side because it doesn't have a red light? Because it knew it gave it a green to get to the far side, which in that particular case was a much safer place to stop. It's a huge equity improvement, and it takes together, the new stuff and why Miovision is bringing these other solutions into the platform. They can all work together for sustainability, for equity, for economics, and for safety. Yeah. I've seen too many videos of that, just the thing that you described, Brian.
Okay. Anything to add, or I got some more comments? All right, so the next newly revealed question, and I'll give you kind of the concept so you can start thinking about it, but lots of new stuff going on. Some of us are a little bit longer in years and decades having worked, and sometimes what I hear, either through talking as a person from Miovision or talking in my previous life on the government sector, is it's all new. We're doing it the old-fashioned way. It's the way we know. We're not going to make changes, and sometimes they have the authority to say we're not going to make changes. So part one of the question is, how does that get overcome? Part two is, how do we get the new generation of staff, up-and-coming engineers, planners, technicians, data people, how do we get them ready to use this? And then how do we take the people who are in the middle of their careers and get them capable of using these new tools? I think some of the fear is the fact that they just don't know how this works. It's very, very intimidating. How do we overcome these challenges so that these solutions don't get stuck on the shelf because of something that can be solved, but maybe we don't know how to solve it yet? So there's my question.
So you shouldn't need a PhD like I have to put this kind of stuff together, right? Like, you just shouldn't need to be able to do that. But a lot of the things that we have done in the past have been very experimental or done in pilots, right? Like, to be able to do that. The key going forward, and this is not unique to Miovision, this is everybody, we're making things easier for the customer, the person who has to operate this on the road, making it easier for them to do that. That's the key. Everything we should be thinking about is making it simpler to deploy technology that improves mobility, improves safety. And that's really, I think, the thing, regardless of where people are in their career. If they're young, maybe it's easier to pick it up, but maybe it's not. There are plenty of very savvy people who are at the tail end of their career who are totally capable of adopting new technology, and people who are young who maybe don't feel comfortable with it. Making it easy to feel comfortable with adopting new things. The day is coming for connected traveler technology. How do you make it easy to implement? It's been an experiment for a while, but how do we make it easy to implement so everybody wants to do it, so it's valuable to do it, so all the benefits that come from it get as widespread as possible, as quickly as possible?
I like the reference to you don't have to be a PhD. Back in my Navy days, back in the day, the acronym we used was NARS, not a rocket scientist. So you don't have to be a rocket scientist impetus to do this sort of stuff. But Craig, please elaborate as well.
Yeah, I think that I've seen sometimes hesitance to try new technologies, and the biggest thing that will move the needle and have someone open up. One, if they're frustrated with the lack of progress on how things are going. You know, we had the decade of action for road safety from 2010 to 2020 with huge new investments and the exact same number of people dying per year at the start and end of that decade of action, even though the goal was to cut it by 50%. So when people start to get frustrated that we're not making an impact, we're not making progress, then the openness to trying new things will increase. And then the other thing that I think can really help is talking about impact and measurable percentage impact. If a company, and we try to do this, we say, because we're about impact as a company, we'll measure what we're doing. How much did greenhouse gases go down? How much did risk go down? How much did delay go down in percentage terms? And if we can say, hey, your friends at this neighboring city achieved A, B, C, D in percentage risk reduction, that starts to get exciting. And then they start to like to think, I'd love to be able to report that to my city council, that we got a 50% or 70% risk reduction here, or 27% improvement in travel time. And if you measure that and report on that, this results opens people up to new ways of doing things, especially if the results seem stuck at the current time. Yeah.
And those numbers, those headline numbers, if you come to our booth, you'll see numbers that quantify the benefits of the signal priority, the numbers that quantify the benefits of the safety studies. One number that Craig stands out to me with the safety studies is your 36-to-1 ratio. This is the deal that we use the artificial intelligence and the near miss analytics to identify a problem. We make a solution. It might be the signal phasing changes. It might be some restriping, signing. It might be something that's a little more capital intensive. But then the solution is out there, and we want to know as soon as possible, okay, is this making it less unsafe? Sometimes the traditional method is to deploy a countermeasure and then wait for that fatal, wait for that serious injury. It may never come, it may come, but it's just too much on the random side. But to now run the analytics and get some quantification about near misses. So talk a little bit about your 36-to-1.
Okay, so 36-to-1 comes from the principle that you should wait at least 36 months or 3 years to make any kind of conclusion based on crash data if there was a safety improvement or not. So for example, when they built this in Austin last year, okay, it wouldn't be until 2025 that you would be eligible to even say, was there a risk reduction or not? But they have their data, they have their feedback loop in 1 month instead of 36 months. And this just enables rapidly accelerating the innovation cycles. Let's say they tried something new here and they're trying to think of whether they're going to deploy it at 100 more intersections. Okay, they got their data and they can roll it out. And those 3 years of safety gains at the next 100 intersections would have been lost while they're waiting. You basically have a 3-year innovation cycle using crash data. And so that's a great number we love. It's 36 times faster. It's rapid. It's the power of speed in innovation. Yeah.
I'm going to pivot back and just make a comment, and then I'm going to open it up for another round of questions. I know what I got last time, so we'll see. Maybe you can surprise me and dazzle me. But a lot of this takes leadership that is not necessarily in this room. The success in Vegas with traffic operations is completely or very much due to the leadership at the agencies. If you go to the RTC, the county, Nevada DOT, those leaders forced and compelled the technical people like me and my staff to get this stuff done, and it wasn't easy. Another thing that they did is they didn't hide from the media. They went full on face front with the media when the media had complaints or whatever. I might wake up to a 5 a.m. text asking, why are they suppressing the cameras for a traffic crash? And naturally you wouldn't want the TV to broadcast a crash that you don't want to see that stuff on your on the morning news. But there were still, I think sometimes the staff was taking that too far. So my point with this is that the leadership and getting us in front of the public, responding to the public, taking that all on, just kind of raised all the boats in the harbor to have us do these things. And that's not something that has to be limited to one city or another city. That's something that can spread around. I highly encourage all of us to engage with the leadership we're getting from ITS America. Laura and Kristen and their staff are doing amazing things. And the things that are being announced by the DOT, whether it's Federal Highways or FTA or the Joint Program Office, they're doing some very, very cool things that we can take advantage of. We have the technology. Now we just got to get those square pegs in the round holes and figure out the Tetris puzzle, whatever it is. We have a great opportunity to do all that cool stuff. So you can listen to me ramble on a little more, or let's have another question or two. All right, Will or Jim, you got to give me a question. Or no, here we are. Okay, excellent. Happy to, he saved you. And Craig's still more spry than I am.
From Japan, engineering, traffic engineering, and what conditions, and mainly the total traffic control system. So you said the first priority is safety. The second priority is the condition. I understand. On the other hand, sometimes the driver can understand the condition of the place. On the other hand, driver cannot understand the safety condition. How to explain first, how to explain that this is the state of safety? At the same time, how to explain this is the safety condition of the place?
Okay, so your question, you're coming to us from Japan, thank you, and you're saying that we have our priorities of safety and congestion, but the driver, yeah, you're saying the driver doesn't know in congestion periods they have to modify their behavior, and they're causing the safety problems. Okay. One thing I will speak a little bit about to that, and we've done these safety studies in at least 15 cities in Japan, and just won an award with the Ministry of Transportation in Japan. So love working there, and you can see some videos from Japan at the booth. There's been a change in thinking among traffic engineers. It's happening right now. It's not finished. Where a lot of the problems, we said we're going to design it to standard, and then if a safety problem happened, it was because of human error. Okay, and if they just would have followed the rules and followed the instructions better, they wouldn't have got in a crash. So it's too bad that it happened, but it's their own fault. So the change in thinking is now saying, as designers, we have to understand the parameters of the elements and components of the system we're designing for. If you design a building here with a concrete column, you need to know the compressive strength of concrete. If you're designing for humans to work in your system, you need to know the parameters of a human. And that includes that humans make mistakes. Okay, so the shift in thinking is to say, we want to learn what kinds of mistakes, what percentage frequency they make those mistakes at, and let's kind of build some safety nets into the system so that when they make a mistake, the punishment for that mistake is not that they pay with their life. Okay, so certainly driver education can play a big role, but a lot of engineers have said we'll never get to a perfect human. All right, we know this in our own personal lives as well. Yeah, except my new boss, maybe. Yeah, you won't get there. So how can we build a system that has fail-safes and redundancies? And that's one of the things we're working on, by measuring the types of mistakes that people make and say, in this kind of condition, they're so prone to making a mistake, we're going to actually take that choice away from them, and we're going to make that choice for them with the traffic control and the traffic signal. So that's a little take on that. But I share your frustration with the kinds of mistakes that drivers make on the road, and pedestrians too.
Yeah, just to speak to that, I think that there really is a benefit to improving efficiency for safety. It's not as perhaps always as easy to quantify, right? But when people are less stressed, when there's less congestion, and congestion's not a bad thing. Congestion may mean that a place is a place people want to be, but unexplainable congestion, the kind of congestion that makes people frustrated, It makes them do stupid things. If we can be more efficient with our traffic control, it can have safety implications that are positive that may have little to do with design and more to do with how do we keep people moving in an efficient way so they feel like the system is doing something for them as opposed to constraining what they can do.
Right, and this relates to a lot of the thought leadership that the federal government's putting out here in the United States when it comes to safety. So we hear Vision Zero, and that is talking about fatalities. That's obviously what we don't want to have happen. But as you look at some of their documentation, that doesn't mean eliminating all the crashes and the accidents. Those are still going to happen. You just don't want them to happen where it will cost someone their life, and that takes into account the limitations that people have. So, that there will still be the crashes, but hopefully they're at less speeds, less impact, less kinetic force and energy, and that gets factored into everything that's happening here. So as I wind down to the last couple of minutes, do you have any last parting shots for our crowd before we sign off?
Yeah, just I didn't know you were going to ask that, but the last part I thought, we're in exciting times in traffic, and the excitement and the potential, I think, is coming through the shift to digital, and digital enables the execution of artificial intelligence-backed solutions. So all these things converging together in an open platform means the possibilities and the future is bright ahead. So I'm excited.
Very excited, and just we're doing a lot of cool things at Miovision. Our booth is over there. It's easy to find. We invite you to come over and chat. There's a lot of opportunities to collaborate, whether you're an agency, government, whether you're a private sector who does a lot of work on studies but need to figure out what are the details of the products and the countermeasures that are deployed. Definitely check in with us, or we'll find you, and we'll have some great conversations. But I appreciate the questions, the conversation, the attention, and we look forward to working with you now and into the future. So thank you very much. Woo.